What we're going to look at in this tutorial is how to prove the continuity of a function. In this specific example, we're being asked to prove whether or not this function is continuous at x equals 1 and x equals 4. And in order to prove it, I need to follow this three-step process. You know, sometimes we can say, well, can't we just look at the graph and say, yes, it's continuous or it's discontinuous? And the short answer to that is no. We need to be able to prove why it's continuous or why it's discontinuous. So let's first take a look at the continuity at x equals 1. I'm going to follow this three-step process that I have listed below. And step 1 requires me to evaluate the function at the given value of c. So in this case, I'm going to evaluate f of 1. And if I do that, I'm going to get 1 minus 4 on the top, which is negative 3. And on the bottom, I'm going to get 1 squared, which is 1, minus 5 times 1, which is 5, plus 4. And if I work that out, I'm going to get negative 3 over 0. Now, if you notice, I have this question here where I said, is it defined? Well, I can see right now that the answer to that is no, it's not defined because I'm getting negative 3 over 0, which is undefined. So I've already determined, essentially, that this is not going to be continuous at x equals 1. It would have to be defined in order for it to possibly be continuous. Now, I can't just stop here and say, well, it's undefined there, therefore it's discontinuous. I still need to go to step 2. I have to kind of continue proving that this is not going to be continuous at x equals 1. So step 2 is going to require me to go find the limit. So if I were to take the limit as x approaches 1, we're going to take a look at that. Now, we are going to look from a graphical standpoint. We're not going to really use algebra to figure out what the limit is. You can, but for my students right now, they're not quite there yet. So we're going to go ahead and use a graph and a table to help figure out what the limit is. Now, I'm trying to find out what the limit is as x approaches 1. And what I'm going to do is I'm going to go ahead and graph this thing. And you can see that graph right here. Now, I'm being asked to figure out whether or not this is continuous at x equals 1. So what I'm going to do is I'm going to make a little table here, and I'm going to start typing in values that are really close to 1. Because if I put a 1 in, I already know that the function is undefined. We already proved that in step number 1. So using 1 isn't really going to help me, so I need to pick numbers that are close to 1. So I'm going to start with, let's say, 0.9. So if I were to use 0.9 for the x value, I get negative 10. All right, let me make another value. Let's go even closer. Let's go 0.99, and I'm getting negative 100. What if I were to go 0.999? I'm getting negative 1,000. So as I'm getting closer and closer and closer to 1, you'll notice that that number, that function value, is getting larger and larger and larger. I can pretty much predict that the next one, 0.9999, is going to be negative 10,000. I'm multiplying by 10 each time, essentially. Now, let's go on to the other side of 1. Now let's say 1.001. I get 1,000. Now let's try 1.01. I get 100. Now let's go 1.1, and I get 10. So what's happening is, as I'm coming in from the right-hand side, let's follow this graph here, as I'm coming in from the right-hand side, as I get closer and closer and closer to 1, this graph is shooting up. Whereas from the left side, as I get closer and closer to 1, this graph is shooting down. Therefore, since the left-hand side and the right-hand side are not arriving at the same place at 1, this limit does not exist. Let me say that one more time. As I come in from the left, I'm shooting downwards, whereas I come in from the right, I'm shooting upwards. Therefore, they're not arriving at the same place. Therefore, the limit does not exist. So I can come back to step 2 here and say that the limit does not exist. not exist. So my function was undefined, my limit did not exist. Therefore, step 3, the answer is going to be no. My limit and my function were not equal to each other. So therefore, the function is discontinuous. Let me go ahead and write that in here. So for step 3, I'm going to say that f of 1 did not equal the limit as x approaches 1 of f of x. Sorry about that there, of f of x. And the way we say this is going to be pretty important. So I'm going to put the little therefore symbol there, and I'm going to write this out here. I'm going to say therefore the function is discontinuous at x equals 1. And I've proven it. Again, we kind of knew that right off the bat with step number 1, but we have to be able to prove it by doing those 3 steps. I have, in fact, proven that this is a discontinuous function at x equals 1. All right, now we're going to repeat the process because now we have to go take a look at x equals 4. So we're gonna have to redo that whole thing. All right, so let me erase what I have here and let's kind of start over. Okay, now, like I said, I'm going to repeat the process. So step number 1, I'm going to figure out what the value, in this case, is of f of 4. So if I evaluate f of 4, I'm going to get a 0 on the top because 4 minus 4 is 0. On the bottom, I'm going to get 16 minus 20 plus 4. So, like the last problem, I'm going to get a 0 on the bottom, which means, once again, this function is undefined at 4. So, I already know it's discontinuous, but I got to keep on going. So now let's take a look at the limit. Just like I did on the last one, I'm going to use a table of values. So I'm going to pick numbers that are really close to 4. So I'm going to say, for example, 3.9, 3.99, 3.999, and then I'm going to go on the other side of 4. So let's go back to my table. Let me clear these numbers out here. Okay. So I'm going to start with 3.9. And I get this number here, 0.3448. Then I'm going to say 3.99. And then I'm going to say 3.999. Again, I could keep on going, but as you can see here, it kind of looks like it's approaching 0.3 repeating if I were to keep on going there. Now let me go on the other side of 4. I'm going to say 4.001, 4.01, and 4.1. So let's look at this table a little more closely. As I come in from the left-hand side, in other words, down here, notice how I'm getting closer and closer and closer to about 0.3 repeating. Same thing as I come up from the bottom, it looks like I'm approaching 0.3 repeating as well. Now if I go over to that spot on the graph, see how it's kind of highlighted here? You can clearly see that these points are arriving at the same place. See that? They're hitting basically the exact same spot. Therefore, I do have a limit here. Even though the function's undefined, I have a limit because they are approaching the same height. And it appears as though that limit is going to be 0.3 repeating, or 1/3. So what I can say for step 2 here is that the limit as x approaches 4 of f of x is 1/3. Again, 0.3 repeating, I'm going to call it 1/3. Now, you're going to learn down the road how to do this algebraically. Again, we're using the graphs right now because we're not there yet, but you will learn algebraically how to find the limit. You're going to find it, I think, to be pretty easy, but for now we're just using the graph. So the limit did exist here. Okay? Now, step 3, the question is, did my answer in number 1 equal my answer in number 2? And the question, or the answer to that question would be no. F of 4 does not equal the limit as x approaches 4. Since those two things are not equal to each other, I am going to then say that the function is discontinuous at x equals 4. It's really important that we specify what value of x we're talking about. We can't just say the function is discontinuous, because just because it's discontinuous at 4, let's say, doesn't mean it's discontinuous at 2 or 5 or some other value of x. So we can't make this general statement the function is discontinuous. We have to be specific. It's discontinuous at x equals 4. Just like for the other one, we said it's discontinuous at x equals 1. Okay, so you want to make sure anytime you're being asked about continuity that you follow this three-step process. Evaluate the function at the value of x, find the limit at the value of x, and then compare the two to see if they're equal. If they are equal, it's continuous. If they are not equal, then we are going to say it's discontinuous. All right, I hope that helped. Good luck to you on these continuity questions.